Assalamualaikum warahmatullahi wabarakatuh. My name is Hana Nabila with the NPM of 1906-356-411, and today I am going to be presenting my final project with the title Optimization of PV Solar Panels Using Hybrid System with Numerical Method Modeling. So the abstract to my final paper is that the optimization of solar panels has arisen through the years as sustainable energy became popular. Yet some rural or remote areas might not have access to the grid, so a hybrid PV system is needed in order to generate electricity from solar energy. One of the implementations are the hybrid systems that not only uses solar power, but also wind power, sometimes also hydro. Focusing on the better efficiency and also practicality of use in rural areas, the hybrid system explained in this paper will mathematically model and simulate the power generation using fixed variables from existing experiments. In addition, this will help the overall growth of renewable energy in all parts of the world, from cities to villages. Okay, so here's the introduction. Firstly, solar panels are one of the most beneficial renewable energy sources to install in countries like Indonesia. Why solar panels? Because Indonesia is strategically located across the horizon, which means that there is a lot of sunlight every day, every time of the year. So that means that the power that we can generate through solar panels is very high. This final project will explain how to optimize the usage of solar panels using a hybrid system, a system that can be implemented easily in remote to rural areas, because many parts in Indonesia don't have access to the grid. And most solar panels sometimes require a connection to the grid. So this hybrid system doesn't need a doesn't specifically need a connection to the grid because they have a battery installed that can save the power for daylight savings. A hybrid system is an integrated system of two or more renewable energy systems and can complement each other, provide a higher quality and reliable power source independent of the utilities grid network. So here are the main objectives of this paper. The first is to calculate the initial current of the hybrid solar panel. The second is to calculate the thermal energy absorbed by the hybrid solar panel. And the third is to simulate an optimization model of the hybrid system. Okay, so what is optimization? Optimization is the process of finding the most effective or um, favorable value or condition. In this paper, we will be simulating an optimized solar panel that uses a hybrid system. Okay, so this is the problem solving part of the paper. First, here are the properties, the variable properties that we will be using to count the PV solar panel initial current. First, we need the electron loading, the diode factor, the resistance series, and the temperature will be from existing experiments. And these factors will get us the initial current. Okay, so here is the mathematical model for this paper. As I said before, we have to find the initial current first, and then after we find the initial current, we can find the efficiency, then the thermal energy absorption, and then the power from the controller, and then the battery charge, and then lastly, the power output for the PV after we have already calculated all the other variables. Next, this is the flowchart that I have made in order to explain how the coding works. So first, you start and then input the solar panel variable conditions, which I have already explained, and then calculate the efficiency of the solar panel, and then calculate the thermal energy absorbed by the PV, and then when the Q of the PV equals to the Q of the electricity, then we can later count the output energy for the PV and then the process will end. Okay, so here's the numerical procedure. First, we have to define all the variables. So these are all the variables that might be needed later for our procedure. So for example, we have the number of cells, and then we also have the diode factor, and then we also have the circuit current and maximum power current, and everything that can be used for our process. And then define the equations there, like that you can see there is equation 2, equation 3, equation 4, and etc. And then we just have to set the parameter and run. And then the iteration will stop when we get the answer we want. And then it will be presented with a graph that I will show you in the next slide. So this is the result of the graph. As you can see, we have two different graphs. The first is using the mathematical model, and the second is the and the second is the data. As you can see, the red dots is real-time data from real-time weather and model voltage and model current from solar PV panels. And the mathematical model uses the hybrid system. So as you can see, the hybrid system produces a bigger current and also a bigger voltage, but also it is not as far as the experimental data. So that means that our mathematical model is is quite accurate to the correct data, to the correct real-time data. Okay, so the conclusion is the modeling, simulation, and analysis of the energy conversion equations describing the behavior of a hybrid system PV and hybrid system for electrical power generation were already presented, and a numerical model based on the aforementioned equation was developed, coded using MATLAB, and the results were presented. The model prediction compared fairly with the PV data at different conditions. So that is all from my presentation. Thank you for listening. Wassalamualaikum warahmatullahi wabarakatuh.